Hello everyone, welcome to another problem session. So this is the last problem in the JEE we are doing right now. We are doing 2024 JEE from India, um, and this is advanced physics paper 1. And in this section you have a description of a problem, the whole setting, and there are 4 questions based on that setting. It's basically there are 4 different problems you might think of it, you know. So let's look at it closely. So here I have 2 keys. There's a key here and the key here. So keys control if a particular branch is going to be active or not. So initially both these K1 and K2 are open. Even when the battery is there, there'll be no current flowing because battery is not connected. Okay, connected to the circuit, I mean, it's connected but connected to this open key, and so the no current will flow. Well, it says that initially both keys are open and then there's no charge, and initially Q at 0 time is 0. Then when you close this key, so this is say close at t equal to 0. Okay, when you close t equal to 0 and this is open, then you have this circuit initially. So initially you're going to have this key is closed, so I don't have to keep. So this was the K1 was closed. So this circuit is basically RL circuit, and at t equal to 0 it was closed at t equal to 0, t greater than equal to 0. So this circuit, you initially the current will build on this circuit. You don't know if you remember this from your studies, but this diagram is very important to remember. So you have a asymptotically is going to reach something, and when the di dt will become almost 0 with time. When di dt is 0, the voltage across here, voltage delta VL will be L di dt. If this goes to 0, as t goes to infinity, this goes to 0, and so this will be 0. So the entire V, this voltage of the battery, will fall in the resistor. So delta VR will be the entire V, 20 volt. So I have a resistor which is 5 ohm. I'm doing actually Q now to find the value of I2. Okay, and so the current I2 will flow according to this description. I2 will flow, and the voltage drop is 20 volt. This is just V equals IR, Ohm's law. So Ohm's law will just give me 5 I2 equals 20. So I2 equals to 4 amp. So this was, and the Q was 4. So let's see now, having done P and Q, now we can see that P is 1, so it could be A, B, and C. Q is 3, Q goes to 3, can be only these 2 guys. So these guys eliminated, these guys still there. When I look at this, so I need to do S to distinguish between the two. R doesn't need to be done, but we'll do it R at the end. Okay. So S needs to be done, but it turns out that S, if you look at this, the voltage of V0 in, so what is the V0? In the description it says that after after T2 after T2 after T2 I mean after I2 has been achieved, open circuit, open K1 and close K2. So if this is opened, then this thing is offline. So at that time it's going to be just this, and at t equal this, let's call it t prime equal to 0, the new t, the current is going is I2, and charge here is qt prime equal to 0 is also 0. So this is LC circuit. So we can do R. I think S requires doing R actually. So if I do R, what's the omega of this circuit? Well, omega is going to be 1 over square root LC, omega 0. So this formula you really have to remember from your studies earlier for LC circuit. Otherwise you have to set up the equation and solve this. It can take a while, but it's good to remember. This is important equation to remember. So square root of L, we need to get the values. L is 25 millihenry, 25 times 10 to the minus 3, and C is 10 microfarad, 10 times 10 to the power minus 6. So all of this is 10 to the power minus 8, and so this is going to be 1 over 5 times 10 to the power minus 4. And so let's say R is in kiloradians. So this is in radian. So this is 10 over 5 times 10 to the 3 radian per second. So this is going to be 2 kiloradian per second. So this actually is 2. To solve S, is what will be the voltage drop across here? Well, it's going to be oscillating, right, with some amplitude. So the voltage across C actually would vary with time, and it will have some amplitude V0, and then it's going to be sine or cosine omega 0 t plus some phase phi. Okay, so how do we figure out this thing? Well, you already know that current, which is let's say Q over there is Q of t, dq dt, so and the Q of t prime equal to 0, dt prime here, Q of t prime equal to 0 is 0, and Q will also at any particular value of time will be, if you look at what the Q will be, Q equals CV, so Q equal to C times delta VC t prime. So it's going to be C V0 cosine omega naught t prime plus phi. So let's use this, okay? So let me erase this and come back to it. because it's filling up. Okay, so I summarized things so far, and this was the current that started this circuit, the circuit we're working with now, and the time t prime equal to 0 when this was closed, and at that time the current flowing there was I2 from this circuit, which now opened at t prime equal to 0 opened. So using a t prime, and we had used t for this and t prime for that for the time. So these were the quantities, and by definition the current and charge will be related like that. This is definition. So this is the oscillating behavior we expect. So if you do dq dt at t prime is going to be just minus omega 0 c0 v0 sine omega 0 t prime plus phi. Now at t equal to 0, t prime equal to 0 is 0. That means this thing is cosine phi is 0. That means phi is pi over 2. That means cosine pi over 2 plus that. So cosine omega 0 t prime plus pi over 2 just will make it minus sine omega 0 t prime. So we got so this will become cosine. So this will become sine. So this q becomes c0 v0 sine omega 0 t prime, and this I t prime will just become minus c0 omega omega 0 c0 v0 sine omega, this will become cosine omega 0 t prime, and it's saying the value of and so if I look at and the second condition was that t prime 0 is 4 amp. So this is 4 amp minus omega 0 c0 v0 cosine of 0, which is 1. And this amplitude, so we absorb this, make it a plus, just the amplitude part. This was, so we are going to get from here v0 is 4 over omega 0 c0. So 4 over omega 0 was 4 times 10 to the power 3 because kiloradian, and c0 was 10 times 10 to the power minus 6 microfarad kiloradian. 4 cancels 4, so we have omega 0 was I think omega 0 was 2 kiloradian. This is 2. Omega 0 is 2 kiloradian, so this becomes 2, and 2 times 10 to the power 2 is 200. So this corresponds to 5. So the answer is A. So answer is A. Okay, I think this is it was a good problem. So what are the really main points here that try and test in this problem is what happens when you have a key open. When key is open, then this whole branch is cut off. That's the second part. In the first part, this was open. When this is open, then this not the whole branch, just the other part, this part gets cut off if this key is open. That's what I think they're trying to test. Everything else is pretty standard. You know, if you do any RLC circuit. So this is like a RLC circuit with keys, which is a pretty interesting way to ask a lot of conceptual problems. So there's a lot of conceptually good problems here. Okay, so I'm going to done with paper 1 now. I will be doing paper 2 soon. So I'll see you in another video. Bye.